going to give you a quick review. Typically, that's how I will do it. I'll give a quick overview of what we've done last time and jump to the new material. So we last Wednesday we did a quick overview of what are the main packaging function. We described that what we're going to do in this class is really focus on the transport and also the protect function. Preserve has much to do again with biological degradation or chemical degradation, whereas protect is more with mechanical damage, and that's what we are after here. So a few definitions. We talked about how different, in an ideal world, different departments, okay, should have an input into the packaging system, okay. And think about packaging when you design your product, okay. And actually going to finish the class with a quick example that I was talking about last Wednesday. I got permission to show some pictures, so I'll do that. Then we talked about two main things, okay? First thing we discussed is that you need to know your product. If you don't know the product characteristics, which are listed here, or some of them are there, or you may need other characteristics as well, it's going to be very difficult to be successful, okay? So we talked about this, okay? We also mentioned that we need to know the environment, okay, in which it's going to be shipped, okay? So, and that was an interesting thing I discussed was the example of a flat screen TV, which has quite different needs, okay? If you think about design and protection, when it's going to be used compared how it's going to be shipped, right? It's pretty safe when it's at the house, it sits on the table or on the wall. It does not need to be very sturdy, right? But during distribution and transport, it needs to be able to sustain it. An opposite example would be something like this, right? Where when it's shipped, it's going to be really hard to damage your phone, right? But as a everyday use, hopefully you know, I've seen many cracked screen. Okay, so it's different requirements. Okay, different challenges. But the phone is going to be packaging is not going to be a big deal, right? So it has to be looking nice and so on. Give you an experience. Okay, it's more a design requirement than protection itself. We talked. Oh, that was a quick thing here. We talked about cross stacking and column stacking quickly last time. And just to give you an example, there was one of you at the end of the class stayed a bit longer to explain or ask a question about cross stacking. So these boxes are not going to be the same, but let's say you have. I'm going to try to press on here. Let's say you have a pallet footprint, so you see it from the top. So you have different types of arrangement depending on boxes size and so on. But let's assume we have something like this, right? Column stacking would be each layer will be the same thing, okay? So column stacking would be on top of each other. So cross stacking would be that the layer on top and on the bottom will be with this arrangement, right? Does it make sense? So you just rotate it 180 degrees, and that's what cross stacking is, okay? Good. So we also talked about distribution losses, okay? And one thing we discussed, and that's very important as we're going to work on your project, and different companies you're going to work for in the future, you're going to have different tasks. But one thing is that will be very important is document your work, right? And also make sure that it's available to other people. Because some distribution losses, okay, may be problem that existed before, problem that has been solved in the past, okay? And without good, communication and ways to access information, you may end up working on a problem that's already been solved, okay? So you're spending resources and time and so on. So we had a few examples of good question to ask if there was a loss, try to understand the problem, okay? What has been changed? Does that happen on a specific location, okay, during a specific time or season, okay? so on, so on. So all of these are things that you should start thinking about, okay, if you're faced with a loss, okay? So good. Okay, that's a quick overview. Okay, we're going to jump through the second series of slides, which is pretty massive. Okay, that's the largest we're going to be dealing with. Okay, and again, there's a lot of pictures. Okay, so that means a lot of me telling stories. Okay, but the good thing about me telling stories is oftentimes, that was the way it was when I was a student, is like it's easier to remember stories than definition, right? So I'm going to go an overview of all that series of slides is divided. Okay, I have a quick review of characteristics of the product, but I'll jump pretty quick on top of it because we just covered that. Okay, then we're going to spend a lot of time about looking at the different mode of transportation. Okay, and what are the characteristics. So we're going to spend time looking at how is temperature control in road, marine transport, and air transport. Okay, we're going to look as well as ventilation system because temperature control is linked to ventilation. Without good ventilation, it's hard to maintain temperature. And we're going to look as well at all products are handled, okay, meaning with pallets, forklift, okay, aircraft containers, and so on, marine containers as well. So we're going to look at this, okay, and then lastly, we're going to have a small section on still knowing your product, but looking at some products with special characteristics, okay, and we're going to talk about perishables, okay, pharmaceuticals, mainly here, which are a pretty major sector of the packaging world. So, quick definition again of the distribution and transport packaging, okay. We have to account for all steps from point of origin to the consumption. That's important. That was in the previous series of slides, okay. So, inputs from all departments, that's very important as well. And the other thing is distribution and transport packaging does not add value to your product, okay? It rather it intends to conserve it. That's very important. Again, I'm going to jump through this because we just talked about this. And let's start with the different mode of transportation and look at what are the environmental conditions. And again, what are the things we're going to look at? We're not going to discuss a lot of shocks and vibration here. We know they are inherent to those different modes of transportation. We're going to look again pressure, okay, temperature, relative humidity, and ventilation, which is linked to all of it. So, road transportation. Okay, so this is one mode of transportation you cannot go without. Okay, because even if it's by rail, most of the time if it's by rail, it's going to be multimodal. It's going to go on a ship on a rail, or sometimes it'll be a trailer on the rail that's going to be on the road after this. But if you go to the end point, it's going to have a road component, right? So there's different ways and options for trailers and so on. But what you'll see, okay, is that if you need temperature control, okay, it is not always good, okay? That's for sure. You have a lot of variation. You can have shipments that will have very good temperature control, okay? They will have shipment where the temperature is going to be all over the place. It depends on the age of the trailer, maintenance. I'm going to see some pictures a little bit later. But one thing that is major is that road transportation, okay, and temperature control trailers are designed, okay, to maintain the temperature of a load. They are not designed, they don't have the capacity to cool down an entire load. That's very important. So if you have a temperature sensitive product, okay, and you load it warm to a trailer, it's not going to work, okay? It's not going to perform well because it's designed to maintain the temperature. So by the way, if you, as you hopefully, I'm going to be able to create some interest through that course with you on temperature and distribution and so on. One thing you may notice is if you go on I-75, okay, typically that's where you see a boatload of trucks, okay. What you'll notice is that trailers that have temperature control, if I can do that, I don't know if you can see over there, but it's pretty simple. But this is the back of the trailer. This is the trailer. If you have trailers with a little tank here, okay, that's typically a trailer with temperature control. And you're going to also see at the front of the trailer, you're going to have a units. A refrigeration unit that will be either Thermo King or Carrier. These are the main company you will see. But that tank here is some diesel, okay, that is used to run generator. If the trailer is disconnected, you can run the refrigeration system on this, okay. But that's the tell point to identify temperature control trailers. And actually, if you go very slowly past of it, sometimes you can see the temperature setting. I'm just curious, but you can. That's the main point. Relative humidity, usually there's no control on this on trailers. Okay, last time I checked this, still not an option. And can vary a lot, but if you have in our hot, humid environment, like in Florida, southern U.S., okay, southeast U.S., you're going to see very high humidity condition in summertime, okay, in those trailers. As the voyage progresses, that relative humidity will vary, okay, because of the refrigeration system as well. So depending on the condition initially, but there's a lot of water that is removed during those shipments because, you know, a refrigeration system tends to condense that water, okay. And I was doing some tests and with one of the truck drivers, they monitored the weight of their trailer. He was saying they were shipping tomatoes from Palmetto, and he said that by the time he's crossing the Mississippi River, is about 500 pounds less, okay, in his trailer just by water evaporation, okay. And that water may not necessarily come from the produce; it will be part of it, but also from the corrugated itself that soaked in a lot of the moisture in storage. So that was interesting. Control atmosphere. What is this? Okay. So those of you who took Principles of Packaging with me or Food Packaging with Dr. Welch, that was in the fall, right? Food packaging. So you probably heard about this, but one way to preserve or extend the shelf life of fresh produce is to expose them to a different gas concentration than what we have here, which is 21% oxygen, okay? Basically no CO2. So how it works is that fresh produce, they respire, right? They take in oxygen, they release CO2, they generate heat, they're alive, okay? So a way to slow down their metabolism, okay, is to decrease the concentration of oxygen and increase the concentration of carbon dioxide. So control atmosphere, and that's different than modify atmosphere, because modify atmosphere packaging is kind of a passive thing, okay? You have, for example, in salad bags that you have at the store, you have different gas concentration in there, but it's not controlled. It's injected, and depending on the design, it should maintain the right concentration automatically. Control atmosphere, there are controls, so you're going to have sensors on board the trailer that can monitor those gas concentration and adjust them, okay? So it's control. So you're typically going to go down in oxygen concentration about 5%, okay? It depends on the crops, okay? You can go a little bit lower. And you're going to raise carbon dioxide to about, also sometimes around 5%. There's some crops that can tolerate higher than 10%, like some berries, okay? But these will be useful mainly on long journeys. If you have like a 2-hour trip, it's kind of useless, okay? Because it takes time for the gas to diffuse as well through the tissue of the product and so on. So that's why you will see that more on marine shipment, okay? But that's one thing that is available is a way to control gas concentration in some of these trailers. Air transport, okay? So temperature control, if we focus on this first, it can be good, it can be quite poor, okay? You can have variation, okay, of minus 30 to all the way even higher than 50 degrees Celsius. There is a lot of variability. And the thing here I want to specify is not just the temperature inside the plane, okay? For air transportation, you need to account for the time inside the cargo, yes, but the more problematic time is when the load is sitting on the tarmac, on the ramp, okay, before waiting to be loaded on the aircraft or after being unloaded. That's where it is challenging, okay? And you you're going to have pretty high variation in temperature. So again, I'll show you data a little bit later that we actually experiment that I ran, okay? Data I captured through the years, but we have shipment that the temperature was controlled perfectly on board the aircraft, okay? Very fine, and good temperature on the tarmac, and we also had some that was like soaring temperature, like you can cook an egg on a container, okay? It's pretty crazy. So a lot of variability. That's why air shipment are very challenging, okay? But things are trending now to improve more and more, okay? And one of the reasons, obviously, air transport has a unique feature that no other mode of transport has, okay? It's fast, okay? And it can go quickly across oceans, okay? So it's not going to go anywhere anytime soon, okay? So if you want to ship fresh strawberries, okay, you know, grade A strawberries from California to top-end, high-end restaurants in Paris, okay, it cannot go there by boat. It has to be flown, okay? There's no other way to do this. So high-end product will basically slowly started to sensitize, I would say, educate people in the air industry to provide services with better temperature control, okay? But what make that change even faster is money, because when people start to ship more and more pharmaceutical product by air, that's what happens these days, okay? It's a multi-billion-dollar industry. Then the airline listen even more, okay? Because if you have a aircraft container that is filled with multi-million dollars worth of vaccines or other product, okay, it is a lot of money, okay? And you don't want to have a claim, right? You don't want to have that container being abused temperature-wise, okay, or anything like this. So there's more and more improvement, okay, meaning temperature with better temperature control inside the cargo hold, and also system or protocols in place to minimize the time on the tarmac, okay? Relative humidity, I'm pretty sure that everyone here, I assume most of you have taken the plane, okay, in your life. I don't know if you noticed, but it's usually pretty dry, okay? And one of the reasons is obviously as you go higher in altitude, the air gets drier and drier. And when you fly, you always mix some of the air from the outside with the existing air, okay? So typically, relative humidity can be pretty low, okay? So we have tests that we measure relative humidity down to 5% in the cargo hold, okay? So that is, it's really dry. And one of the issues is when you ship, again, fresh produce, okay? They don't like losing moisture, okay? So that's a big issue. If they lose about 5% of their weight in water, usually you cannot sell them anymore. They'll look terrible, okay? So that's important. Also, some cargo compartment, as we will see, may have ventilation system and temperature control, so you're going to have usually lower relative humidity. But there's also some planes where they just have a cargo compartment, it's just a big box, okay, you close the door and that's it. There's no air exchange. So in those compartments, you can have very high relative humidity. It depends, okay, if there's ventilation or not. And pressure-wise, you're going to have variation about 20-30%. That's typically what happens when you go up in altitude. Here we have 1 atmosphere pressure. In the plane, usually is going to be about 0.8 atmosphere, okay? So that's 20%. So that can be pretty challenging as well, because that's also something you probably notice if you have, that's one thing you do. If you have like water bottles with a straw, and you forgot to disconnect the straw, it's going to be, you can have a surprise. Also, you know, yogurts or bag of chips or anything like this, they get puffy, right? Okay. So that has an effect on packaging system. Okay, if you ship sealed product by air, you're going to see those pressure variation that can play a role. And again, for pouches, for medical devices and things like this, that is important because you don't want to have any break in the seal of these pouches. And delays, if you have a time sensitive, so you're going to have delays, but regardless, usually air transport is faster than any other. So, but the delays become an issue if you have a load sitting again outside on the tarmac. And think about this, because you can have a shipment going from Miami, let's say in the spring, and a bit later it can be pretty hot, and it goes up north to Canada, Toronto, somewhere like this. So you can have a very wide variation in that temperature, okay? So that's what makes them challenging. Yes?
Are there not systems in place to account for the pressure variation, or is that variation with because I know like there's some pressure systems inside a regular.
Yeah, they control it, but they
Yeah.
still control it to about 20%
Okay.
lower than what we expose. it.
Okay, so that's with
otherwise,
variation.
at higher altitude, that would be even lower.
Okay.
Yes, good question. So, cargo. How is it transported? So about 55% of all the cargo is carried on passenger aircraft. So with you, with your luggage and everything else, okay? And about 45%, it's about 50-50 in a way, right? It's carried on Combi. I'll tell you what it is, a Combi plane. Or cargo aircraft, which is just no seats, except for the pilots, obviously. And it's just going to be cargo. So, and the time-wise, and obviously it depends on what type of flight is it, international or domestic flight, but about 54% of the time is spent on the ground, and about 46% is spent in the air, okay? So, obviously short flight, it might be different, but in general, okay, about half and half. So, this is an example of a Combi plane. So you have two decks, right? On an airplane, you have the lower deck, or the belly, okay, where you're going to have containers there. And you have the upper deck, where usually you have passengers, right here. A Combi plane is a plane where you have both sections, okay? Part of the upper deck will be cargo, and part of the upper deck will also be passenger, okay? I don't think I ever flew in one of these, okay? I flew in a cargo plane, but not in there. So that's what a Combi plane is. So a full cargo plane will be cargo all the way everywhere on the top as well. Okay. Okay, it will take me a week or two to get used to those switches. There's two, so it's complicated. So this is to give you an example, okay? I'm going to maybe keep that low. So this is to show you test that we did, okay? We looked at, these are thermocoupled wires, so we measured temperature everywhere. Bunch of fruits and oranges. Okay, we run tests in an aircraft container in the lab, and we also instrumented, because we didn't want to fly with oranges to different countries to be stuck at agricultural inspection and so on. So we use water bottles. I don't know if you've seen those aquapods. They look like produce actually, and we put temperature sensor in them, not all of them, and we ship that container everywhere. And here you don't have to remember or study these graphs in any ways. This is just an example to illustrate what we noticed, okay? So the first example is a ramp transfer at JFK Airport. So ramp transfer means that your cargo is taken from storage, in this case it was cold storage, and is brought outside awaiting to be loaded on the airplane. So that's what's called a ramp transfer. So on these two series of graphs, on the top one, you have the product temperature, so the sensor that are embedded in those water bottles. And in here, you have the temperature of the wall of the container. I wish we still had a container here, but I don't know if you've seen them on the tarmac, but that picture is terrible. But what they are is super light box, okay, with super thin aluminum wall, okay? So aluminum is a very good conductor, so we didn't want to have wires outside, so we measured the inside temperature of the wall of the container, which are very close to the temperature of the air outside, okay? Because of the ability of the aluminum to conduct heat. So this was in April, end of April. So you see that temperature outside were about 15 degrees Celsius, a little bit of variation, but products were fine. No temperature change whatsoever during that time, okay? And this is the flight from JFK to Gothenburg. That was a stop, and then we went all the way to Dubai. DXB is Dubai. So this this shows you the flight. So this is the product we're on board. Okay, this is takeoff. Okay, you see the pressure that drops from 1 atmosphere to about 0.8. Okay, so we go down, we got a berg, we stop a little bit, and so on. So you see here, so this was the temperature inside the cargo plane that was set at 10 degrees Celsius. So pretty good control, and the products are totally fine. Okay, so this is an example of everything going really well. So this is when we arrived at Dubai. Okay, so it was around noon. Okay, and look at this. This was actually a very quick RAM transfer, meaning the container didn't stay outside very long. So about 30 minutes. Okay, so look at this. It went from about 10 degrees Celsius, and this is the top of the container, about 65 degrees Celsius. This is really, really hot. Okay, and look at this. This was enough. So that line that started to go quite up. This is the average temperature of the first layer of water bottle. So this is a lot of product. Okay, and that temperature in very close time. Okay, went up by a bit more than about 2 degrees. Okay, that is significant because this is half an hour, and these airlines will tell you half an hour is what they're going to do, but as you'll see, it can be hours. Okay, and if it stays hours with 65 degrees Celsius on top of that box, it's going to be cooking in there. Okay, and think about if you have produce, if you have chocolate, you don't want to spoil chocolate, right? Okay. Things like this. So this is a second example, okay? In this case, what you have is a very extensive delay in RAM transfer. That was a trip from Dubai to Nairobi in Africa. So what you had here, look at this. The container was taken out, and it took about 8 hours before it was loaded on the plane, okay? So in here, okay, what you see is this was in the morning. So this is sunrise, okay? As soon as the sun came out, actually it was about 4 in the morning, 5, 6 in the morning. So you have the temperature that started to go back up pretty quickly, okay? And look at our product in there. So when it was loaded in the plane, okay, let's say this product has to be at this temperature to maintain optimal condition. It's doomed, okay? From the get-go, it's doomed because a little bit like the truck, okay? The aircraft is not designed to cool down, okay? It can be maintaining a constant temperature, but it's not designed to cool down. So all of these products with the thermal inertia, they kept warming up, okay? And then, that load would have been lost. This airplane, by the way, okay, was a passenger airplane. And look at the temperature in the cargo hold. It's about between 15 and 25. So just to give you a reference, I don't know if you're really good with Celsius and Fahrenheit conversion, but it's in the 70 to 75 degrees Fahrenheit, okay? Typically on passenger aircraft, I'm going to turn on the lights to make sure you don't fall asleep here. On passenger aircraft, temperature will never be below that range, around 70. Anyone have an idea why it has to be maintained around that temperature?
Expensive?
So, what do a lot of people these days bring with them when they fly? Yes.
Electronics.
Yeah. But I would say they have more fur. Pets. Okay. Live animals. Okay. So every time you have live animals on board, typically you cannot lower the temperature. Okay, so whatever it is, the live animals are going to have precedent on the temperature. So typically you're going to have on passenger flight, unless there's a cargo specified with for perishable or something like this, it's going to be relatively warm. Okay, and the thing is, usually you cannot as well decide where the container is going to go because the location of the container inside the cargo is dictated by the weight distribution of the plane, right? So I don't know if you've seen those pictures of plane tilt up on the car. Somebody didn't do their job right, but so it has to do with weight balance. So this is one another example here. And by the way, if you notice and you're curious, so here the pressure didn't go back up very high because narrow B is actually pretty high up. Okay, so the pressure over there was about 0.85 atmosphere compared to sea level. And over there, this is the RAM transfer to illustrate again. You see the influence of solar radiation. There are some clouds passing by, but that's again pretty high temperature. So all of these graphs, okay, and all these things I showed you was to illustrate 2 points, okay? And that's the first, it's hopefully you're going to believe me better since I showed you some data, one. But it's to illustrate that, you know, I don't want you to leave here saying, okay, air transportation, I'm never going to ship product from my country to there. It's not true, okay? It can be pretty good conditions, okay? But it's not always the case, okay? There's things that happens, and that's challenging. But the benefits of sometimes shipping by air, you know, overcome any other ones. Okay, if it has to go, it has to go. Okay, so but it's an interesting thing. So now we're going to jump through the last mode of mode of transportation. We're going to focus on is sea or marine transport. Okay, this is kind of the best. Yes, sorry.
I have a question. So it might be like a dumb question,
No,
but
no, no.
for flights that are just packages, why does it not get colder? Why does it get hotter? Because in my head, the higher you go, the colder it is.
Yeah, with cargo planes.
Yeah, just cargo.
So they will still control the temperature in those cargo holes, and usually they don't want it to be freezing.
Okay.
So they have temperature control in those. And if they don't have temperature control, that means they don't have ventilation. So it will actually get really cold near doors and things like this. But other parts of the aircraft can be quite different. So if you're close to, for example, because they mix the air as well. So you have the bleed air from the engine. So it's really hot air. They'll mix it with the air outside to adjust the temperature they want. And if you're close to a duct where that bleed air from the engine comes by, it can be really hot. We actually run tests. That is a long time ago, but we had data logger. There were plastic data logger that was placed in containers. They actually melted. Okay, so that happened. Okay, and also heard horror story of pets
Melting?
not melting, but freezing close to doors. Okay,
Oh,
because it's close to doors, it can be really cold. So there's variation. Okay, but typically it's not going to get freezing cold. And the other thing is, as you mentioned, you said electronics. So electronics are also sensitive. So if you have something, you don't want to expose it to extreme temperatures. So marine transport is actually provide the best temperature control condition or relative humidity and so on you can get. Okay. Some of the reason is that those marine containers, which the one that are temperature controlled, have like super thick insulation. Okay, big urethane wall. Okay. And they're really good. Okay. Actually, I don't know if you've seen, but there's so many containers. People are starting using them to build houses and things like this. So it's pretty neat stuff. But relative humidity control is available. That's the only mode of transport you're going to see that. Control atmosphere is going to be available as well. And that's one aspect that is useful is for those long journeys. If you're talking about weeks, okay, to get somewhere, or at least a week or many days, then having a way to play with the gas concentration will help with produce, okay? So you'll have a lot of asparagus coming from Peru, okay? That's going to be coming in the U.S. or some part of Mexico, maybe marine, and then it may be flying to the U.S. It depends, but you see a lot of this. And Thermo King and Carrier have their own respective technology. So Thermo King, if you look at this, it's the AFAM Plus technology. So I'm going to try to remember. It's Air Fresh Automatic Monitoring. It's very close to this, okay? Air Fresh something, okay? I forgot. And Carrier have their own thing, okay? But they can control the gas concentration. What is that? I always forget. I'm terrible with acronyms. Marine is, again, for this is really good. You may have more chances to lose your container at some point, but it's they have good condition in this. So handling techniques. Okay, let's see my watch. So we're going back. So all of these product and load handles. So if we go back to road transportation, okay, one thing that is essential now for any types is pallets, okay, or skids sometimes we refer to. So most products now are unitized on wooden pallets, okay. Basically, it's a platform that can be picked up with kinds of forklift trucks, different orientation. You have different style of pallets, okay. I think honestly, if I don't know how many of you would be interested, but I think we could probably do a whole semester just on pallets, okay. Like you could do a whole semester on cardboard boxes, okay. But there's a bunch of them, a lot of variation, different quantity and different characteristics. So this one here on the top is what's called a block pallet, okay, because you have blocks, okay, that instead of stringer like this. So the block pallet, one of the advantages, they can be easily forkliftable in 4 directions, okay. So because those pallets always sometimes have to be turned, to be loaded, and so on. So that's one of the things. You can have pallet with one deck, okay. You can have pallet with double deck that can be flipped for any reason. So might be a lot more sturdy as well. Stringer pallets are a little bit more sturdy. They may have some opening on the side to be able to slide and move, but they are not necessarily designed to be handled in 4 directions. Typically, it would be a 2 direction. And the deck board is kind of important, okay, how it's designed, okay. And one of the reasons has to do with, as well, something we talked last time about the strength of a corrugated box. Remember what we said? Where is the strength of a corrugated box? The corners, right? So on a pallet, okay, what you want, okay, is the corners of your box, depending on the pattern you're going to be using, but you don't want it to fall in the hole, okay? You want it to be supported on the deck. And sometimes you will have pallets with full deck, okay? But you can have also pallets. I don't know if any of you worked in the warehouse or Publix or Target where you see one of those, but you can have pallets that basically have like a board here, there's no board, there's like big gaps, okay? So if you have something like this, then you may have problems during distribution and transport as well. An alternative to pallets is what's called slip sheets, okay? Slip sheets are just sheets, okay? They can be made of really tough fiberboard paper or plastic sheets, okay? And you have the load directly loaded on these sheets, okay? So how it works, okay, is you have a special attachment on these forklifts, okay, that will come, okay, and on these slip sheet, you have a little lip, okay, that always basically exceeds the load itself. So the forklift comes, okay, and grab that lift and slide the load on the forklift itself attachment, and then move it around and slide it up back and forth. I have a video on this. Let's see if I can play it now and we can discuss it. I think we're probably going to finish class with this. Hopefully it's going to be still there. Okay. So we'll turn off these lights. That will give you an idea about, and I want you to be critical to what the guy says, okay? Because he's not telling. Anyways, we'll discuss it.
Hi, my name's Tony Leach. I am Supply Chain Solutions General Manager for SBS Worldwide. Today I am at Felixstowe at our freight station to actually demonstrate how we can implement slip sheets into the publisher's supply chain with the support of our EDC system.
By re-engineering the supply chain utilising the slip sheet process, this film highlights substantial payback compared to traditional palletised and loose loads. Benefits include using slip sheets instead of wooden pallets allows for 10 to 15% more product to be loaded into containers. Significant reduction in material handling costs. Decreases loading and unloading time by up to 60% compared to floor stack loose load. Slip sheets weigh 20 times less than wooden pallets, saving shipping weight.
So you understand, a floor stack loose load is just boxes, okay, not unitized.
The first part of this film will demonstrate traditional container loading methods, such as palletized and loose load floor stacking. We will look at the inefficiencies and waste of the traditional processes. Then in the second section, we will show a live demonstration of the slip sheet process and detail the advantages of utilising slip sheets in the supply chain.
As you can see, in a typical palletised load, we would probably use around 40 pallets to actually load into the container with a customer's goods. And you can see the actual volume that they would actually take up. We can see that, at least 15% of the container, sometimes more, is made up of wood and air.
Here we see a container that has been hand stacked at origin. In this scenario, we can build a container to maximise volume. However, this requires a considerable labour overhead on the loading and unloading process. Time and motion studies suggest that on average, depending on carton size and weight, it can take 4 warehouse operatives 2 to 4 hours to devan a 40-foot container. Not only do you have to ensure the manpower
Look at the guy, where he's doing. He's actually stepping on your boxes.
is in place at the receiving DC, there are also health and safety risks that have to be managed. So even though we are achieving much greater container utilisation, there really is the potential bottlenecks of unloading the goods and subsequently getting them to market.
This is terrible.
In this scenario, we have loaded the container with a traditional pallet load. The books have been received on printer pallets. The advantages of using the pallet load is speed in which we can devan the goods with a forklift.
But this is an example of a terrible path. Okay, this is really.
However, the disadvantages you can clearly see is that you do not achieve maximum utilisation of the container volume. The pallets account for 10 to 15%, and with traditional loading patterns, up to 30% of the container is potentially wood and air, leading to significant waste within the supply chain. There is also the consideration of pallets not reaching necessary standards regarding heat treatment and fumigation.
Okay, here we see an example of Far East printer pallets that were not suitable for the European and UK marketplace or were broken and damaged on arrival. As you can see, this is significant waste within the supply chain. By implementing recyclable slip sheets, it takes out this element of waste, and if you bear in mind that 200 million trees are used each year in the production of pallets, that is a significant impact on any green policy. So by implementing the slip sheets, you can eradicate this waste from your supply chain. Okay, in this scenario, what we've done is actually loaded the container using the slip sheet process. This enables us to get maximum utilisation, maximum volume, maximum container loading rates. But at the same time, we can actually devan at the same pace as we would do with a forklift. So we're getting the same economy in terms of devanning and unloading the containers we would do with a pallet, but we are achieving maximum volume and maximum container utilisation.
We have a partnership with Cascade, who supply the forklift push-pull device. Attaching the push-pull device allows you to ship and receive unit loads on reusable, inexpensive slip sheets rather than pallets. The push-pull attachment can be installed or removed onto a standard forklift and does not require removal of the original lift truck forks. Another important point to remember is that freight insurance brokers see no difference between pallets and slip sheets as far as premiums. In this clip, you can see how efficient it is to load and unload products using the slip sheet push-pull device. The grabber clamps down on the exposed slip sheet and smoothly pulls the product onto the widened forks. To swiftly palletise the goods, simply place the load over the pallet and cleanly push the load into position. We have the option of using reusable rubber or strengthened card slip sheets dependent on the load type. The slip sheet process is proven across vertical markets such as the pharmaceutical and beverage industries. There are clear advantages of implementing the slip sheet process into the supply chain, along with our EDC system, to generate cost reduction and increase efficiencies.
Okay, let me just stop it here so we have time to discuss it a bit. What do you think about what he was saying here? You agree with him on everything? Yes.
I guess I'm a little confused if they're using the slip sheet, they still have to load it onto a pallet?
Seems like at some point they put it on a pallet. So, one thing, do you think is actually as fast using slip sheets and pallets? To me, it cannot be as fast because you see how the way it took to. Obviously, there's some benefits, right? Okay, they can adjust the load maybe and do things that definitely lose less space for sure. But the speed obviously cannot be the same thing. Okay, you're going to have variation there. Stability of the load as well. If you have something light, I think at the beginning, if I read, they had like duffel bags or fabric, so that's pretty light. Okay, so on slip sheet, I would say it probably worked very well. But if you have something heavy goods, okay, on the slip sheet, and you see when he was pulling it, I don't know, but the boxes were shifting, right? So it's different. Okay, so it does not necessarily behave and provide the same thing. Obviously the big advantage, okay, we're going to talk about it later, but some of the big advantages of slip sheets, okay, compared to pallet. Let's see if I can blow this up. I'm going to finish with this, okay. They're economical, little space, they are light, they can be recyclable, okay, but one thing, and that's what you're pointing out, is that it must be available throughout the distribution chain, okay. And obviously it's slower to operate, more expensive. But if you don't have that attachment at the point of reception, okay, some people are going to be swearing, okay, and climbing on boxes and unloading it. So that's one of the issues that can happen. I'm going to let you go for today. Thank you so much. Have a great long weekend, okay? And I'll see you next Wednesday.